Joins are the backbone of relational databases, helping us connect data across multiple relations with precision and power. At the heart of all joins lies the cross product, also known as the Cartesian product. This operation pairs every tuple from one relation with every tuple from another, creating a foundation for building meaningful relationships between data. Joins refine this process by narrowing down the results to tuples that meet specific conditions. Let's explore the inner join retrieves only the matching rows. The left join includes all rows from the left relation, even if there's no match. The right join works similarly, but focuses on the right relation. The full join merges everything, keeping unmatched rows from both sides. Whether you're a beginner or an expert, mastering joins is essential for building powerful relational queries. Watch the full video to dive deeper.
So once again, good morning, students. So we will continue the topic of relational algebra, and in last class, we have started the relational algebra, and we have seen there are different operations in relational algebra. So some are unary and some are binary operations in relational algebra. For example, unary is the very first operation is select and then project, and then we have seen a row also. Other than this, we have started some set the operations that has taken from a set theory. So one of them we have seen is union, another we have seen is intersection, and one very important that we have seen is set difference. This is like a minus, okay, and this is also called except. So three names are there: minus, set difference, as well as except. Right. Then now we are starting one category of the operations in relational algebra, and all of the operations basically are based on this set theory operation, which is called cross product. Cross product, and sometimes it is also called a Cartesian product, and its representation is like this: cross or a Cartesian. Right, and this is very a generic, you can say, operation which joins two relation. So let me read out for you. This Cartesian product, it is denoted by R cross S. If R is a relation and S is a relation, then it is denoted as R cross S. It combines two relations, R and S, and producing a new relation with all possible combinations of tuples from R and S. So you have to make every possible combinations from R and S. How you are going to make? Let's see. Some of the important points about this cross product or the Cartesian product: every tuple in R is paired with every tuple in S, right? This is like, an English explanation of a cross product. Every tuple, that means every relation, is paired with every tuple in S. And there is one check you can see. If you are taking a cross product or if you are taking a Cartesian product, so relation with number of tuples equal to number of tuples in R multiplied by number of tuples in S. Right, so this would be the final number of tuples in the resultant answer. Yes, so on its own, I mean alone, it's not very useful, this Cartesian product. But when you apply with other operations, for example, select and some condition, so it will give you a very handy results, and it will give you some important results. So alone, it's not very a handy, or it's not very useful. But when you combine with others, so it will give you some handy and some usable results. So to explain a Cartesian product, I will take a relation R, and here let's see that this relation is having two attributes, A and B, and in this relation state we have, let's take A1 and let's take A2, and here we are making it simple. We take B1 and we take B2, right, students? And there we take the relation S, and here in this relation S, I will take two more attributes, C and D. And here I will take C1, and here I will take D1, and here I will take C2, and D2. So now we want to make a cross product or the Cartesian product of these two. So few points about that. Count the number of tuples in this. This is the first tuple and this is the second tuples. So how many tuples are there? Two tuples are there in this relation R. And how many tuples are there in this? Count the number of tuples. This is 1 and this is 2. So two tuples are there in this relation S, right? So the final product or the final Cartesian product will have how many rows? 2 into 2. So 2 into 2 rows would be there. That is 4, right? That is 4. And how many attributes would be there? All the attributes from R and all the attributes from S. So first it will have A, then it will have B, then it will have C, then it will have D, right? Then it will have D. Now from the definition, what it is saying that you have to make a combination of every tuple with in one relation to the other tuples in the other relation. For example, if this is T1 and this is T2, and let's say this is R1 and this is R2. So you have to make a combination of T1 with R1 and with R2, and then you have to make a combination of T2 with R1 and R2. Let me solve this. So A1, B1, first you have to take A1 and then B1, right? And then you are making a combination with the first tuple in the second relation. So what will come? C1 and D1 will come, right? This is the first row. Then the second row, still you have to continue A1, B1, you have to take A1, B1, and then you have to take C2, D2 because this is over. So C2 and D2 you have to take. Then this first row or a first tuple is exhausted, that means it is finished. Then you start with A2. So A2, you will take first A2 here, and then you will take B2 here. And similarly, you have to make a combination with all of these three. So first, what will come, students? C1 will come, and then B1 will come as a first, a combination. Then in last, again A2, B2 will come. So A2 is coming and then B2 is coming. Here, what will have? C2 and D2 will come. C2 and D2 will come. So all the rows are exhausted. I mean, all the rows are finished. We made all the combination. Count the number of rows. So 1, 2, 3, and 4. So total number of rows were expected 4. So I hope this answer is correct. This is about what? Cartesian product. This, a join. It's a kind of join only. It's a raw join. Raw join in a sense, it will never check any condition. Just it will make a combination with every other tuple in the second relation. And sometimes it is very, most of the time it is not very useful, but sometimes with other conditions, it will become useful. Now we have some very well-known joins in relational algebra also. And these joins are actually useful when you have to query from multiple relations. So suppose that you have this first relation and you have this second relation, and you want this data and you want this data and you want to combine here. Okay, you want to combine in a third relation. So obviously what is required? Some kind of a join is required because you are joining the relations. Then how many types are there? There are 4, fundamental types are there for a join. The first one is a natural join. It is represented by this symbol, right? Then on this natural join only, we have something called left outer join. So see, you have to make a natural join and then you have to make a left outer join like this. We'll come and we will study what is a left outer join and what is right outer join. Okay, and then the third one is, as I said, right outer join. So first you have to make a natural join and then you have to make like this a right outer join. This is third kind of a join. Then you have a full outer join also. So first you make a natural join and then you take left as well as right. So it will become what? Full outer join. So these 4 kinds of joins are there. Other than this, there are some others also, but they are very famous and they are very at the beginning level. So we'll start with only these 4 kinds of a join, and we'll try to solve some of the queries also using these joins. So first we'll study the natural join, students. Natural join. So natural join, as I said, it's a binary operator. binary operator. What is the meaning of binary operator? Two relations are required in this. And it is written as I said, it is written as using this symbol. So only you have to write this expression and it will become a perfect relational algebra query. If this R is a relation and this S is a relation and you are taking R natural join S, so this is a valid query in relational algebra, right? The result of the natural join is set of all combination of tuples in R and S that are equal on their common attribute names. So suppose that there is a relation and in which there is a common attribute C, in which there is an attribute C. Suppose there is another relation in which again there is an attribute C. So this natural join, that means it is going to join naturally, and it will join naturally on which attribute? The common attribute, because the common attribute will give it or will give the interface to join. Consider this employee relation. We are taking the employee relation from day one. So things will become easy with this employee relation. In this case, how many attributes are there? Name is there, employee ID is there, and department name is there. So how many attributes are there? Three attributes are there. Then there is a relation department also, DEPT with short form. And how many attributes are there? This is the first attribute and this is the second attribute. So what is common between these two? Obviously, the common attribute is department name, department name. So the natural join will take place on the basis of what? Department name. And how it is going to take place? It is exactly same as the cross product only. So you have to start with the first row and you have to actually take a combination with all these tuples in a second relation. But you are considering only those tuples in which the department name values are equal. Otherwise, you don't consider. If you are taking a cross product, let's say, so how many rows are there? 1, 2, 3, 4, 5. So 5 rows are there. And how many rows are there? 3 rows are there. So 5 into 3, 15 tuples will come in a cross product. Just we have seen a cross product, but it is not a cross product. It's actually a natural join, and in which we will consider only the values of department name where they give the same results, like finance is equal to finance. So only we have to consider this. And the resultant, a relation will have how many tuples? It will have all the tuples, and the common attribute, sorry, is not going to be repeated. So you will have a name, right? And then you will have employee ID, and then you will have a department name, okay? And then at last you will have what? A manager also you will have. So 2 times it is there, but we will take only 1 time. But if it is a case of cross product, so it will appear 1 more time. That's the main difference you have to keep in your mind. So how many attributes are there? 1, 2, 3 and 4, because this one is common. And if it is a case of cross product, then 5 attributes definitely will come. So let's see how we can take a natural join. Now we are not taking a cross product, we are just taking a natural join, right? And this is a natural join. So Harry 3, 4, 1, 5, finance equal to finance, they are matching. So first row, obviously Harry will come, and then 3, 4, 1, 5, and then finance, and manager is what? George. Okay, students, so here are we, and we are actually taking a natural join of these two R and S relation. So how many attributes will come in the final relation? Only 4 attributes will come. Department name is a common attribute, so it will not come. So here, this is the final thing you have. So name, employee ID, department name, and manager. So you start from here, students, and you have to check only the department name when it is equal. So finance equal to finance in first, a combination. So we are taking Harry 3, 4, 1, 5 finance and George. So this is taken. Now finance is not equal to sales, so it is not coming, and finance is not equal to production. So again, it is not coming. These row are not coming. Then we have to move to the second one. and we have to start again the same process. It's like a cross product only, but we are just checking a one condition. So sales is equal to finance. No, it is not equal to finance. So they are unequal. Then sales is equal to sales. Yes. In this case, it is working. So we have to consider Sally 2241 sales and then Harriet. So Sally 2241 sales and Harriet. This is we are going to take. And then George, again, finance. So finance is matching with the this thing finance. So we are going to consider this one also. So George 3401. So 3401 is coming, and then finance, which is a common thing, it is also coming. And then again, George is coming. So here it is a George, and here it is a George. Then it is not matching with the production, so we are not considering this. Then Harriet, again, sales is not matching with finance, but sales is matching with sales. So we are going to consider here sales. And then Harriet 2202 sales, and then Harriet, right? So this is coming. And then if you come here, human resources, there is no value of human resources. So we are not considering at all. So finally, how many, the tuples I have? I have only the 4 tuples. And if it was a cross product, then 1, 2, 3, 4, 5, 5, and then 3. So 5 3s are 15, tuples would come in case of a cross product, but it is a natural join only. So nothing, we are having only the tuples which are matching on the department name. Common attribute is the department name. Then we come to the second one, which is called left outer join. Left outer join, right, students? So left outer join works this way. So this is exactly a natural join, plus we have to take some of the remaining, the tuples which are left out or which are remaining in the first relation. So if you are taking, this is employee and this is what a department, this is employee and this is what a department, and you are taking a left outer join. So first, obviously, because this is a natural join, so you have to perform a natural join. Then some of the tuples are going to be left out and they are going to be remaining. Yes, so those you have to consider in the final table. How you are going to consider, let's see in this case. So what you are applying here is the left outer join operation in this. So exactly the same process for the natural join. See, cross product and then natural join, and then I'm coming to the left outer join. So if you have understood cross product, so I think there is no problem in natural join. And if you have understood the natural join, so I think there is no problem in, or there would be no problem in left outer join. So start with Harry 3415 finance. So finance, a student is matching with sales. No, it is not matching. Finance is matching with the production. No, it is not matching with the production, right? So now I'm coming here. Sales is matching with sales. Yes, sales is matching with sales. So I have to take Sally 2241 and sales. So Sally 2241 and sales. And here you have to consider Harriet also. Okay, don't bother about this row, students. This is coming because it was left out only. Right now we are here. Then George 3401 and finance. So it is not matching at all. So we are not considering right now because finance is not matching with this. So right now it is left out, and right now it is left out. Then sales, again matching with the sales. So we have taken this sales, right? And then executive is not matching with any of these value. So how many are remaining? This one we have already taken. This one we have already taken. How many are remaining? So finance is remaining. Then again, this finance is remaining, and then this executive is remaining. So we have to consider in left outer join all these values one time only. So you see, up to here, Harry 3415 finance. But what about the manager? Who is the manager of Harry? Actually, this value is what? Null. You have to write null here. And then if you are coming here, finance. So who is the manager of George? there is no value for this. So again, you have to write null. So by omega, here the value is null. You can write phi null or you can write omega. Any values you can write it. So executive. So here, if you see executive, so we have taken these three and plus these three are coming as it is because this manager is not here. Manager is not here. So we are taking omega and we are taking null. Let me give you this way. First, you have to start with the natural join only. So where is the natural join? On sales, it is a natural join. So sales are coming and sales, I mean Sally. Here Sally is coming. And then again, sales is matching with sales. So what is coming? Harriet is coming. So we have taken Harriet. Okay, Harriet. So these values are coming. Then how many are left out? Only three are left out: finance, and then executive. So we have considered these also. So either you can write it at this point or you can write it after that also. The results would be same because there is no order in the relation. So you can write it at last also or you can write it at the same time also. Absolutely no problem. Then the next one, student, is what? A full outer, right outer join. So right outer join is based only on the natural join. And here you see that right outer join joins on the right relation. And where is the right relation? This department is the right relation. Exactly the same process. Exactly the same process. Now you have to consider only those tuples which are left out in second relation, on a relation which is on the right side. So this relation department is on the right side, or you can call it a second relation. So start with, are they matching? No, they are not matching. Are they matching? Yes, they are matching. So you have to consider this, sales and this. And then are they matching? No, they are not matching. Are they matching? Yes, sales and sales are matching. So you are considering this row. It's a natural join. Up to this point, this is a natural join. Then sales is taken. What is left in right relation? Obviously production is left out because this is conceived, this is already taken, but production is left out. So here you have to write production and Charles. But the problem is, in this department name, who is the employee? The employee is what? Null. And here the employee is what? A null. In other sense, in this case, you may think of, in English, you may think of a query which is asking, list out all the employees with their manager and also include those managers under which there are no employees, right? So Charles is a manager. Under him, there are no employees. This is the meaning of this full outer join. And Sally has a manager, Harriet, and Harriet has a manager, Harriet. Harriet himself is his manager, right? And then there is a manager, Charles. Under him, there are no employees. In a similar way, in a left outer join, what is the English version of this? List out all the employees with their manager, and if there are no managers for the employees, include those employees also. So in case of Harry, there is no manager. In case of George, there is no manager. They are very happy guys. Okay. Tim, there are no managers. So again, Tim is a very lucky guy because he's not having any supervisor. So he's independent, right? This is the meaning of left outer join and the right outer join. Then on the other hand, we do have something called full outer join. Full outer join. So full outer join, the steps are very simple. First, you take natural join, then you take left outer join, and then you take right. So that means it is connected in both the ways, left and right. So what is the meaning of that? So you have to first apply the natural join, and then whatever the rows which are remaining, or whatever the tuples which are remaining, you have to consider those. And then whatever is remaining or whatever are left out in the second relation, you have to consider that thing also. This is the meaning of full outer join. So let's quickly take a natural join first. Finance equal to sales, not equal. So we are not considering. Sales equal to this. So yes, it is there. So we are considering. So we are considering this. It's a repetition only. Similarly, finance is not equal to sales. Finance is not equal to production. So we are not considering that. Sales is equal to sale. So we are considering sales and this value will come. Harriet with value will come. Right, students? So how many are left out? This is left out. This is like a left outer join. I'm repeating. And this finance is left out. And this is also left out. So you have to include these three tuple. So you are including Harry, then you are including George also. So you have included George, and then you are including this happy guy Tim also. So you are including Tim. Then what is left out in this relation department? Production is left out, right? So department name production and the manager. Okay, so manager is Charles. Under him there are no employees. This is about the full outer join. And the query would be what? English query would be what? List out all the employees with their manager. Also include those employees who are not having a manager, and also include those managers under him, no employees are there, right? So it's like, a union of these two, not a union exactly, but it's like, a left outer join and a right outer join. So it's a combination of what? Left outer join and the right outer join. Okay, students.